Welcome to my talk. This talk is how we use GitHub to continuously integrate GitHub. It's actually a talk broken down into 3 stories. It has 2 main parts to it. One of them is to show you how we work, which we're very much a fan of, and hopefully to sell you on some part of that, to help you believe you can do it, and maybe more importantly than that, to show you some of the building blocks towards the end that you can use to sort of automate any workflow and hopefully make it as nice and fun as we get to have. I am Ben Lavender, but I go by Booga everywhere. I don't even put my name on the slide. I work at GitHub, and I work on workflow tools. I maintain CI and deployment things. I play with things like exception trackers. And I'll tell you the first story about why I do that. It's a very short story about my first day at GitHub, which is you sit down, there's somebody there to partner with you, and this happens. Somebody deploys github.com to production, and they do it with a chat command. It doesn't take very long. This is a long deploy. It usually takes about 45 seconds and not 130. And when they're done testing, they just simply undeploy. Compared to the other ways I had worked in the past, this was like a dodgeball in the gut. It was a very, very big change for me. And that's the end of the story about me, because it's not really a talk about me, it's a talk about GitHub Flow. GitHub Flow is the workflow that we use. It's based on 4 rules. The rules are that anything that's on master can and will be deployed automatically, immediately. Always work on very short-lived named topic branches. Open pull requests very early, very often, to get feedback. And once you merge, again, immediately deploy. It results in a workflow that looks kind of like this, but this is kind of boring, so I made another story. This is a story about one fix at GitHub, one named topic branch. The first step of anything is to decide what you're going to work on. And I've put a slide about Agile that I found on the internet, just to stress that I don't actually have anything I can tell you about that. GitHub gets to be lucky in that we're developers and we work on developer tools, so usually when we decide what to do, we take ridiculous suggestions from Twitter or something like that. We don't actually have much to offer you, I think, in terms of Agile or Scrum or feeding that back into the cycle. But once we've decided what to do, step 1 is to make a quick topic branch, right? You do your work, blah, blah, blah. You make a commit into version control, and then you type git push. After this, several little things happen. They all happen asynchronously. There's so many changes going on at GitHub at a time that if you had to do each step of a change in order, everybody would be waiting on everybody else all the time. So we have several things that have to happen. You have to open a pull request, right? That happens very early. Somebody will respond to it, and you'll get some of that feedback in, but again, happens very, very early. There'll be notifications into a chat room so that everybody can see what you're working on. There will be some automatic builds that occur. These will also notify everybody. If they don't pass, or even if they are, they're added to the pull request so that they make a portion of the pull request there. You'll need to respond to automated test failures, of course, just like you'll need to respond to big chunks of feedback that you can get. We'll do all that sort of conversationing on a pull request, and then we will deploy. And this looks something like this. This is part of actually just testing code at GitHub. The first thing you type is to deploy what repository, what branch, and to where. The word Spider Skull Island here, which we've taken from old James Bond films where villains live on volcanoes and tropical islands that look like skulls, is actually an environment, just like production or staging or anything else. And I wanted to call it out because we don't actually have a completely separate staging environment. We have a number of test environments which are backed by production data, but which only staff can access. So very early in the process, you will throw some code out onto production, play with it against real data, test it yourself when you finish the deploy. Make sure that works. Eventually, it will become time to deploy it to actually production. So production is the default on this deploy command right here. When it goes out, our robot, and when I say our robot, what I actually mean is a sort of constellation of chat robots and supporting applications, will automatically merge master into the branch. Broadly speaking, we deploy 100 times a day or something nutty like that. And the result is that by the time you have started something and finished something and ready to deploy it, 3 or 4 other things have happened. So we automate that process. After master is merged, the tests come back. The robot, again, another application, notices that the tests have passed on a branch that you tried to deploy. So he'll go ahead and deploy it automatically. And when he's done, he'll let you know that he's done, and he'll give you some links to some tools, which I'll go into a little more detail later. This is an exception tracker, a statistics grapher, and a database performance monitor in particular. While you're testing something on production, watching for errors or something like that, the robot will help you out in a couple ways. He'll lock it so that nobody else can go, so that nobody can step on each other's toes. Eventually, you will come back to your pull request, click merge, which makes it become part of master, and whoever is waiting around for production to do the next thing will get to go. The robot will notice that you have merged master, and I don't have screenshots of everything that will happen, but he'll unlock production here, create a new error tracking widget associated with your deployment, and a couple other little things. And that's the end of that first little story. It's the result of GitHub Flow. Perhaps much more broadly, GitHub Flow is a version of continuous deployment, which is something that we could talk a lot about, where people have put a lot of fancy words on it. But really, continuous deployment is about deploying and developing very quickly in very small, well-tested increments. It's a lot of fun for developers. I don't have a lot of bullet point slides, but this one's awesome. The workflow is really simple to learn. When you bring on a new developer here, there's only 2 or 3 things they need to get used to. There's no release process. The actual development process is separated from the concept of what to do. Feedback is really frequent, because you might be deploying and sending 3 or 4 things out a day. Every deploy is very low risk. We deploy very small increments. So there's no once a week, or I can't even imagine anymore, once a month moment where all the changes you've bundled up go out, and if one of them breaks, who knows which, and it's a very stressful, long day. Those just aren't there. The very small changes mean that merge conflicts, the actual both sort of syntactic and semantic, so to speak, of lines conflicting and people using things different ways, these become trivial. When you're only pushing 50 lines at a time, it just doesn't seem to come up. And the last is that you feel good as a developer, because there's no point at which there's a release process or a manager or somebody else that comes in terms of the deployment. You get feedback on pull requests, and we insist that somebody else sign off, usually with a sort of thumbs up emoji. But you're not asking for permission at any step. You're hoping somebody likes it, and you get to say, I'm going to go ahead and fix that without asking for a lot of permission. Again, it goes very quick. That brings us to our third story. When I tell people about this, I very often hear it seems kind of impossible that I could ever get there. And this is a story starring you and maybe Jackie Chan. It's sort of a 2-part story, right? Because really quick workflows like this take an awful lot of practices, right? Probably the single biggest piece of discipline that you need for this sort of workflow is to make tiny changes. To recognize when you're working on something and you're halfway done and you realize that you're pulling out something and refactoring it, that you need to just stash this or keep this branch here, step away, make a new branch, make that a tiny little change, push it out, get it shipped, get it to production, pull master in, merge it into the branch you were working on, and move it back and forth. We make really tiny changes. This is, when I made this slide, this was the last 15 or 20 pull requests on GitHub. The biggest one is adding 600 lines. Most of them are under 20. And that comes from being able to recognize when you're working on something more complicated than you initially thought. The second practice, as opposed to tool, that you can help yourself with is to let your application understand development, right? This is the top left corner of github.com for staff members. It knows what version is deployed to itself at any given moment. Oh, sorry. On the other end of the top end of github.com, we have a lot of stuff that will happen in a little AJAX request as soon as the page is loaded. It'll tell you how long it took the page to load, exactly what views rendered, how long it took to render, how long it spent in cache time, how long it spent in database time, exactly what queries it had to load. If you did an Elasticsearch query, it will actually output the JSON of the structured query. And it does all that because it understands that you probably need on production as a staff member, because you're probably testing something to see what kind of features it's creating. The last practice, I think it's the last practice I'm going to talk about, would be to use feature flags. This slide is for me because I'm about to show you some JRuby. We do this for almost everything that ships on github.com. There are preview features, so to speak, which is to say that if we add something like, say we're going to add, I have a slide here, status context. We'll make a method called status context enabled. We have a pile of code around the concept of feature flags. These feature flags allow you to, they get propagated everywhere, so they exist inside controllers. They're usually dependent on either a user or a repository, so those models also know if a particular feature is enabled or disabled for them right now. Often we'll ship them when they're very, very new to just one team as opposed to the entire company. The top thing there, preview features, is sort of our default. In this case, XYZ feature enabled is something that will never ship to enterprise, so we just go ahead and turn it off. And abilities team enabled, quote unquote, is something that's being shipped just to a very small team at GitHub that is, in this case, doing some refactoring on some permission things. This is one of the most valuable things we do when we go back to that small changes thing, because it means that when we ship a feature, it's usually a one-line pull request. It almost always looks like that, and it's simply one line. Shipping a huge, giant feature, when we have moments where we ship huge repository screen updates, giant database schema changes, things like adding code search, which was a huge year-long engineering project. The final pull request was one line. It happened in the middle of the day. It didn't cause any significant downtime. Nobody was particularly worried about it. And this is something that even if you took nothing away from this talk, you could go back, start using, and use it to break down your pull requests. And I'll say it takes a little bit of getting into because it has a little bit of tension with some of the more Kanban style story building stuff, because it means you'll often be pushing pulls that are not necessarily something that affects a user story. Sometimes these three practices will mean you're pushing a little something which is in support of something you're going to do soon, but you want to get a little chunk of work out and about. But once you get past that tension, you'll be much happier. The second part of the story is you still working with some tools that you'll need. When you automate your workflow, you need a way to interact with it. There's a saying in English that a fish doesn't see the water he swims in. At GitHub, we don't notice that we use chat because we use chat for absolutely everything. We have an extremely powerful chat robot, one that I have given talks on and can literally talk about for an hour. He has any number of very powerful commands. In this case, I picked 4. We can run builds, deploy, merge pull requests, and set environment variables for applications. all from chat. Our entire operations team works entirely from chat. Things like disabling repositories for being abusive, things like rebalancing file servers that have gotten uneven in terms of traffic, things like routing and derouting traffic between different chunks of the application, for lack of a better word, determining is the database healthy, running MySQL analyze queries, show me the last 10 slow queries on github.com. All of that comes straight through chat commands. Well, I'll come to it. You need to be able to track exceptions very well. We wrote our own. I'm not sure that I would recommend anybody write their own exception tracker anymore because there's a lot of really, really good products out there. Ours, those little pictures underneath the graph represent deployments. So we can go back and see if we had a spike, what happened. But if you're going to deploy several times a day, you need a high degree of confidence that what you deployed worked. And that means that you need to have a high degree of confidence that if an error occurred, you saw it and you know why. Our errors come in generally in real time. We have a background exception rate, mostly because people do things with Git that I don't even know how you would make a computer do that sort of thing with text encoding, but people do it all the time, every day. But most of the time, our exception tracker is pretty clean. So if I deploy a small change, after I'm confident that it does its job and confident it doesn't work, and I upgrade it to production, I can be very confident after running it for 5 minutes that it's not going to cause any further problems. Related to error tracking are graphs. It's incredibly important that you're able to track the change of something over time, especially if you're working with something that has a potential performance impact. Adding a statistic to GitHub is incredibly easy. This is something where we wanted to see how many people were failing after an API change. So how many people were no longer getting valid statuses after they were changed very slightly. This took 2 seconds to write. This gets exported again into chat, of course. This is another great example of how important it is to be able to put things in chat. When we have problems, our operations team can call up graphs into chat. So if an ops person finds something that they think is relevant or is the cause behind an issue, pulling that issue into a chat room so that everybody has shared context on it can help grease communication quite a bit. And the last tool that I want to sort of talk about is that you need to have all these tools that I just talked about be something hackable. And this is just a picture of something from an American TV show from when I was a kid, of these little green monsters that build things in underground caves. But it's no good to have your tools be a different team. It's really important that the people who are developing a web project have ownership of the tools and are able to hop in and fix them. Otherwise, the tools become something that gets in their way, and they find a way to work around them. And there's sort of two ways to do that. One is to sort of have sloppy code that nobody is afraid they could possibly break any worse than they are. We're more a fan of something that's really, really, really standard. So we're a Rails shop, so the important tools like this, we're making an effort to convert to well-tested, really uncreative Rails applications so that if somebody jumps in, it's very clear. The point is that you want everybody on your team to be able to say, boy, I sure do wish it would automatically do X if this particular CI test failed. That shouldn't be a thing that's out of their reach, right? If you want to add a workflow rule or edit a workflow rule, that should be a thing that every single person can touch, fix, and edit. So this comes as sort of the second half of the concept of continuous deployment, which is that it's really important for it to be automated. Each of these is a step in the little story that I told earlier about a single commit at GitHub. And these are the ones that computers do for us. These are the steps that happen automatically in response to a user action that would have happened anyway. And most of them are built on webhooks, right? Webhooks, very simply, are basically an outgoing API. Basically, when something happens on GitHub, a post goes out to a little web server you set up that accepts a huge payload of JSON or XML. It has a lot of information about the given event. So for example, you have a git push, and it will push a bunch of commit info to your webhook receiver. And I want to interrupt briefly and say a disclaimer, because although I'm about to talk a lot about GitHub, because it's the API I know and like quite a bit, this stuff is not specific to GitHub. Stash, Bitbucket, Garrett, 3 or 4 more that I heard about this week, all have the concept of webhooks and automated stuff. GitHub has a particularly rich set, everything from issues being assigned, labeled, commented on, pull requests being opened, tests failing, repositories being starred, somebody follows you. All of this stuff can actually create an action that you can respond to. And that means you can automate huge swaths of workflow. To use them on GitHub, if you start on most repository pages, you would click down at the lower right to get to the settings, click on the left to get to the webhooks page. There's a bunch of built-in services where you don't even have to set up a receiver. Things like chat systems and a lot of CI services out there, continuous deployment services, just tons and tons and tons of them. But what I'm going to talk about a little bit here is straight up webhooks, that big button in the upper right. And I think the best way to do it is just to show you an example. We'll do a really, really basic one that posts when somebody creates an issue to a chat room, right? The timeline looks sort of like this. A developer or a project manager or whoever posts an issue on something like GitHub. GitHub will send an issue event to a webhook receiver. This is a little bit of Ruby pseudocode that would say, I just got a pile of JSON. In that, I can get a user, an issue number, an issue title, and it's hopefully pretty trivial to post it into a chat room. This is about as trivial an example as that can get. This is the full payload, or not even, that's actually about 2/3 of the payload of one issue creation event. And again, these events come in on everything you can do with an issue. It includes everything about the repository it's attached to, everything about the user that created the action, kind of everything you could want, right? So raise your hand if you use CI, right? It's a very common thing. But most people don't build their own, right? But it's actually very simple to build your own. You would simply pick the push event type, right? We have a number of event types, so notice git pushes. Again, this is 1/1000th of the information that comes by with every commit. On a push, you actually get information about every single commit that occurred, whether or not it's a merge commit that has distinct commits or not, who wrote the commit, which GitHub user pushed the commit, all sorts of good stuff like that. The workflow looks a little bit like this. You push a commit to GitHub. GitHub pushes a push event to a CI server. The CI server adds a commit status, which is another feature of the API, to mark a particular commit as halfway through a build, starts a build, waits a while, and then updates the status. And note that the notifications for all that stuff come out of GitHub. So this little CI server is actually very simple to build and doesn't actually even have to be CI, right? It can actually handle quite a wide array of things that you could do to say, check for things. So maybe you want to make sure that every time you do a check-in, there are no libraries with vulnerable dependencies. Maybe you'd like to have a code linter run, which is separate from tests. You don't want it to fail the build, but you'd like it to tell you if you're doing things just stylistically wrong. Maybe you want to run some deeper static analysis that you're not running locally and see if you have any other advisory gotchas. It's the exact same workflow as a CI server, and it's actually really easy to build. This is just more stuff of that example. The GitHub API also supports the concept of deployment. we don't actually deploy for you, but we track them. I'll get to how things can actually deploy for you. So this next little workflow is based on 2 different event types, again, all outgoing webhooks. There's a deployment creation and a deployment status. Again, tons of information come out. You can actually drop arbitrary payloads into it. You create a deployment on one end. GitHub sends out an event to whatever server you have that would say, okay, it's time to deploy because a deployment has been created, which will send status updates back to GitHub saying how the deployment is going. Those status events can come back to this server or a different server. We use exactly this to separate the concept of notifications about deployments from other services. So the exception tracker that I showed you a minute ago actually just subscribes to deployment status events rather than be something that every other system needs to know about. When a deployment is finished or started, we get a different thing that talks about it in the chat room. Again, a very basic system, nicely decoupled, independent, standalone systems. And the last example I wanted to show you here is sign-off, right? This is something that a lot of people think GitHub is missing, but it's actually very easy to build. And what I mean by that is that a lot of people use GitHub in a way where you work on a pull request, and eventually somebody comes along and says, cool, or thumbs up, or happy face, or the ship it squirrel, or any other number of happy emojis. To build something like this, you take the issue comment event. When a developer creates a pull request, it sends a notification to a QA team or a manager or anybody else who cares. That team goes off and does whatever they need to do to be confident about it. They just mark a comment with a thumbs up, for example. That can be used to trigger any other number of servers, right? We have this little deployment server, which is what I said, well, why don't we deploy it when we have the QA team sign off? It all happens automatically. You go all the way to the far end of this little screen here, and the deployment server will deploy, close the issue, and maybe drop a comment into the issue at random, saying how the deployment went. I want to point out what's really amazing about this stuff is that if you use some of these tools, nothing happened here that a human being wouldn't have done anyway, but their actions were augmented, right? Again, this makes your workflows really, really powerful. It doesn't help to have a workflow where somebody who wouldn't have had to sign off on something has to go off and do something else, because then the workflow is getting in their way. If you can just take their analysis of a comment that they would have made anyway and make that be the trigger for a lot of powerful stuff, you can increase the power of every action you do, get more done every day. There's any number of workflows you can build. I've talked to a couple of people here this week who have workflows that pretty much cover whatever. We have something like 100 outgoing webhooks. There's only 24 here, but several of these have sub-events. The issue event covers everything, again, from labeling to assignment to creation to deletion, open, close, blah, blah, blah. But it just shows up as one thing right here. To use that, there's almost 200 API endpoints, maybe over 200 these days, that lets you store everything about the state of your application, deployment statuses, and even create new commits. So if you have something that wants to say, compress images. I've seen somebody who has a system where when you push image assets that are part of your website, it downloads it, compresses all the images maximally to whatever set of settings they want, and makes a new commit with the newly compressed images and attaches it to the same branch. Really whatever you would want to think up. If you'd rather buy this kind of thing instead of build it, there's actually tons of stuff. Hubot is a chat robot, which may be the most important thing I think that any developer can be using is a chat robot. That's open source. This Heaven project right here is an open source system for deployments, like I was just showing you. Janky is a robot-enabled GitHub webhook front end for Jenkins that you can run locally in-house. Travis CI, Circle CI, CodeShip, etc. are full stack continuous deployment solutions, much like I showed you at the beginning. DPL is a library for creating deployments on multiple services. So not just Heroku, but Heroku, AppVeyor, tons and tons of things. Several. I mostly know the ones that are big in the Ruby world, so I don't know which ones are there. But DPL has something like 25 backends now and can be used to create most any sort of deployment system you want. And Sprintly is just something that uses a lot of these API and webhooks that I was just showing you about to use GitHub as a backend for Kanban. And that's the end of the third story. Because honestly, you know, it's something that you can write for whatever kind of workflow you want. The talk went about 10 minutes faster than I thought, so I wish I could try and pronounce thank you, but I'm going to leave this kitten here to hypnotize you if there are any questions. There is a lot of information on the channel. For the busier chat rooms, what we tend to do is sort of move discussion separately from the operations. It's really important to know what people are doing to watch if a chat room is locked, for example, if a deployment is locked, who's doing what. So it is a lot of information, but there's a lot going on. And if you want to have a deeper conversation, you do another chat room. I think we have about 250 people in 212 chat rooms. We tend to break it down pretty granularly. So the question is it possible to block operations with webhooks, which is to say, in case somebody is not, I suppose, authorized, can you say that if no one says cool, then you can't do it? And the answer right now is no, although you could make pretty easily an undo button that simply unmerges it if somebody you don't like does it. That's probably messier than I would like, but you can get to a pretty close place.
How long did it take for you to get to this flow of deployment?
Question is, how long did it take to get to this flow? And the answer is, it developed over years. It's becoming a more popular flow, and the truth is that there are huge shortcuts. So some of those buy versus build slides a couple slides ago, some of these basically do the whole thing. Things like CodeShip and Travis actually have the concept of build, test, merge master for you, and deploy, send it out the door, sort of all wrapped up. And things like the exception tracker, that's a perfectly purchasable service. Graphing is a little more expensive to purchase, but if you want to spend one really nasty day setting up Graphite is not the end of the world. And then there's any number of front ends for Graphite. Which I would also recommend definitely setting up because Graphite alone is really not worth it. But I would say that you can actually sort of move a little further towards this every single day, especially if you're willing to use some of these services. There was one.
So our webhooks you mentioned durable and like reliable in terms of when, for example, the receiver is dead and doesn't respond, will the webhook will be repeated later?
So the question is, will webhooks be repeated if a receiver is dead? And the answer is not by default, but we do have a whole management console where you can redeploy by hand and see the response code that your web server gave and all the response text that your web server gave for the last 100 events or something like that. So it doesn't actually automatically retry. But there are a lot of troubleshooting tools to help you make that stuff reliable. I write these tools internally every day, and I honestly can't imagine working without things like redeliver for testing. Mm-hmm.
Hi, I've got a practical question about this chat tool that you use. You said that everybody is using this chat tool, issuing commands and seeing the results to communicate in the team. Isn't that distracting?
I would say no. It is a little bit, there's a lot of information. Again, we have 150 people working on stuff pretty much all day. We do tend to break things down. There's sort of a point where if you have too many developers working on a project, it doesn't matter if it's in a chat room or not. We do kill a lot of information. Like we've put a lot of effort into our chat clients so that like build notifications are sort of obviously background noise, and you can find the one you care about, but it doesn't actually like jump out at you. Deployments are sort of background noise, so you can find the ones that matter to you, but they don't get displayed to you. When people talk, it's made more important, if that makes sense.
So you filter some.
We don't
information.
filter, we style. We help, we use visual cues with a little bit of custom CSS to help you understand which messages are important and which messages aren't.
Thank you.
All right, thanks.